Hello and welcome to our channel. I am Priya Barik, volunteer of Shivi Forensics. In this video, we are going to discuss about analytical methods used in forensic toxicology. Before moving forward with instrumental techniques, let us understand the basic definition of forensic toxicology. Forensic toxicologists defined as the study of toxins or poisons and their effects on human body with applications in legal investigation. Its main objective is to detect and identify substances in biological samples such as blood, urine, tissue, and other body fluids. The main role of forensics is solving criminal cases by finding out the cause of death. Instrumental techniques plays a crucial role in forensic science and are used in many areas including trace evidences, fire and arson investigation, toxicology and controlled substances. These techniques are used to identify and quantify drugs, poisons and other toxic substances in biological samples. Here are some techniques, and in this video we'll be mainly focusing on the principles, application, advantages and examples of these techniques. So starting with gas chromatography, it works on the principle of separation of compounds based on their volatility. It is the most suitable technique to analyze volatile substances including alcohols, drugs and volatile poisons. Its high precision and sensitivity towards volatile compounds makes it a preferable technique for detecting alcohol levels in blood. Moving on to another technique, GCMS or gas chromatography mass spectrometry. As in the figure depicts clearly that this technique is a combination of GC and MS. Here the sample in the GC column, after getting separated in the GC, gets eluted and enters directly into the mass spectrometer, where they are further ionized and detected by the detector. Since GCMS is a combination of GC and MS, hence the principle is also a combination of GC, that is separation and identification of molecules from complex biological matrices. It is most suitable for confirmation and quantification of drugs, poisons, and any other substances in complex biological matrices. High sensitivity and specificity makes it a more reliable technique than compared to GC. For non-volatile substances as well as volatile substances, it is a confirmatory test for the drug of abuse. For example, methamphetamines, opiates, or cocaine. High performance liquid chromatography or HPLC. This chromatography works on the principle of separation of compounds in a liquid phase using a high pressure pump to push samples through a column. It is most suitable technique used for non-volatile compounds such as drugs, poisons, and metabolites. It is most versatile and capable of analyzing a wide range of substances such as barbiturates and other pharmaceuticals, drugs in blood samples. Moving on with liquid chromatography mass spectrometry or LCMS. It is a combination of HPLC and mass spectrometry and is therefore works on the principle of HPLC and mass spectrometry together, that is separation and identification of compounds. It's most common for identifying and detecting both small and large molecules and complex matrices. Its high sensitivity and accuracy makes it more reliable for the screening of novel psychoactive substances. Let us know what is novel psychoactive substances or NPS. These are synthetic psychoactive drugs that are generally not under international regulatory control. They are further classified as synthetic stimulants, synthetic cannabinoids, synthetic hallucinogens, and synthetic depressants. The most common examples of such substances is LSDs, benzodiazepines, and opioids. Such substances are easily identified using LCMS. Now coming on to spectrophotometry. Spectrometry works on the principle of absorption of light by a sample to quantify substance concentration. Types of spectrophotometry: ultraviolet visible spectrophotometry, infrared spectrophotometry, and atomic absorption spectrophotometry. The ultraviolet visible spectrophotometry is cost effective, simple, and versatile. It is a non-destructive analytical technique suitable for large spectrum of organic as well as inorganic compounds. It is used for qualitative as well as quantitative analysis, which determines both the presence and amount of certain substances. Whereas IR, that is infrared spectrometer, is used for identifying and studying chemical substances, their functional groups, and materials. It is capable of analyzing solid, liquid, and gaseous samples. The atomic absorption spectroscopy. As previously mentioned, spectrophotometry works on the principle of absorption of light by the samples. Applications: it is most suitable for the detection of heavy metals, whereas UV and IR are more suitable for the detection of drugs or any other abusive substances. Advantages of AAS is that it is highly sensitive towards metals and is therefore used for the detection of arsenic poisoning or any other heavy metal poisoning. Coming to immunoassays. Immunoassay is a laboratory test that uses antibodies and antigens to detect and measure the presence or concentration of specific substances in a sample. It works on the principle of antibodies to detect specific drug or toxins. Their types are enzyme-linked immunosorbent assay, that is ELISA, radioimmunoassay, and lateral flow immunoassay. It is generally used to detect proteins, lipids, and nucleic acids. It is a rapid screening test for a variety of substances. It is a quick, easy, and cost-effective method used as a preliminary drug testing in samples like urine or blood. Inductively coupled plasma or mass spectrometry used inductively coupled plasma to ionize the sample and a mass spectrometer to detect the ions using ion source. The applications lies as detection of trace metals in biological samples. Advantages: it is extremely sensitive to trace elements and used for detecting heavy metals and environmental toxins. Here is a comparison table of the above mentioned techniques, which I have almost covered up during the explanation procedure. Thank you.